So what is it precisely you need to clear up? How to, is it the Excel part?
Like, do we just copy and paste the cells into Word?
Yeah,
That's it.
That's like
for the Excel part.
4 pages.
What? You can get it on one page.
No, the 101 takes like 2 pages.
Yeah, but you can okay. You could start that table of 100 values on a new page, and you could make that page a 3-column page.
Also,
Yeah.
is that fine with you? As a format?
Well, I mean, which do you think I would prefer? You know, lots of pages with lots of white space, or it all on one page? You know, of course it's fine. You know, especially if the only thing on that page is that table, and it's not clashing with anything else on the page.
Also, would you like double spaced or single spaced?
I don't mind. 1.25 is good. It doesn't look too squished. Yeah. Yeah. So just copy it into Word. But my tip is for the large table, start it on a new page and make it like a 3-column page. Yeah. What else do you need now? Yeah. Come here. Let's see. If anybody else has it typed, we can have a look at it. Looking nice. Looking nice. Yeah. Make the font a bit smaller and you can squeeze it onto 3 columns. But actually, do you know what? This is fine. That doesn't bother me. That doesn't bother me. I don't think the sentence is quite right. I noticed the area of the lower rectangle is about the same as the area of the upper rectangle and had a difference of about 2 over 3. I don't quite think you mean that. I think you mean to say they were both about 2 over 3. Yeah, so here you just need to say when or what makes it converge. So you never mention the fact that you make more and more pieces. So the end going to infinity. Oh, that's okay. Let me put it into Oh, you made the same mistake as your buddy Angela. The summary and the conclusion is for both tasks. So that means you only would have gotten half the conclusion marks there. So that definitely needs to be fixed. Oh yeah, this looks nice. Only a couple of small little things, but nothing major. So it's all on track. The biggest thing is you need to fix that though.
How would I summarize the first portion? What do I include?
Kind of really just saying the same stuff that you're saying here, you know, like there isn't anything more insightful. So, well, I thought the end was like 11. I think what you need to say is expand up to 4.
Yeah.
So you need to make that a little clearer. No. Actually, retype that sentence.
Yeah.
It's not clear at all. Give it another thought about what you're saying, okay? Right. Is anyone else wanting me to check anything they typed?
For F, part 3 and 2, can we just have a table for it?
Yeah, because you're doing all the same stuff
Yeah,
again, so there's
like
no
the whole thing
there's no need to retread, you know. So just put it in a table. What's the expression? No need to retread worn ground or something. Is it something like that? Anyways, yeah, just put it into a table. Yeah, isn't that what you said? F part
2 and 3.
Yeah. In task 2, when they ask you to do everything again, but for
Different X.
different X and A.
Yeah.
Yeah. Anything else?
And we shouldn't use the same value used in class. We should switch it.
Well, like what did I use for X?
Minus 0.1.
Yeah, so if you want to use minus 0.01, you might find that you get an even better approximation. I don't know. And you don't have to use 0.5, but you should use something close to 0.5. Like you could use 0.45. It's no big deal. I think the 0.5 a lot of people would pick anyways because the question said pick a number between 0 and 1, minus 1. Yeah. Because why would you pick anything else other than the one in the middle? I don't know. Okay, what else now? Silence means, how should I interpret this? I don't know.
The thing is, sir, when you're typing in the formulas, the font can't be changed. It's like stuck to a single font.
Yeah, that's fine for the maths, and that's what it
fine.
should be.
Okay.
The maths font is a different font.
Then the typing should be Times New Roman then.
Yeah. What's the story? What's going on, guys? Do we have questions? Do you want to work on your coursework? Like, what's the vibe right now? What's the deal? Huh?
I've already asked.
Okay. But you had no
I have a
workbook. Yeah. Okay.
It's about conditional probability.
Yeah. Well, let me just actually take the attendance so I don't forget. Mahmoud, Gafar, Amjad, Zara, Mo, Daniel. Daniel, you're in class and it's 10 o'clock. It's amazing. Are you not sleepy? You're good. Okay, that's great. Sevi, Sabrina, Alfreda, Arya, Judy, Young Pang. Oh, have I got everybody except Mahmood? Amna, Mariam. There you are. Okay. Right, what page?
98, sir.
98. 98. Now, just so you know, the answer for 6,
Yeah.
I didn't type the 8 when I typed the answer. I typed 0.57 and the answer is 0.857. So if that's your question, then that's that. Okay.
No, it's number 14. It's going to be this.
Yeah, 14
Yeah.
on page 98. Okay. Let's have a look at this one. There are 3 boxes. 1, 2, 3. A box containing 2 gold. Okay, so what's the story here? There's gold, silver, and bronze, is it? No, just gold and silver.
Silver, yeah.
So a box contains 2 gold. A box containing two gold, 2 silver, and a box containing 1 gold and 1 silver. 1 gold and 1 silver. So 2 gold, 2 silver, and 1 gold and 1 silver. A box is chosen at random and a gold coin is removed. What is the probability that the second coin removed will also be gold? So you took out a coin. So you picked a box, you took a coin out and it's gold. What's the chances that the other coin that you take out next is also gold? Now you realise, okay, well if you took a gold coin out, you definitely don't have which box? The middle one, yeah. I mean, that's...
Yeah.
So it must be the case that you have either the first box, and so you're guaranteed the next one is gold, or you have the last box, which means you won't get gold. So let's see what happens here when we calculate it. So we want to calculate the probability that the second is gold. So I'll just write second equals gold, given that the first equals gold. So you know you got a gold for the first one. So that's the probability that the second is gold and the first is gold over the probability that the first is gold. Now, because we're talking about first and second, a probability tree really seems natural to use here. So you first pick 1, 2, or 3, the boxes, and each box is equally likely. So you have 1 over 3. Now, if you pick the first box, you can either get gold or silver, but really you can only get gold because there's 2 gold in it. So I'll just write gold, gold, and that's guaranteed. In the second box, what can happen?
No, sir, isn't it 3 over 6, the probability of getting gold first?
It might, it could. I'm just doing it formally, but you're thinking as like there's 6 coins and yeah. I just really want it structured here. So for the second one, so you can only get silver, and for the last one,
Silver,
and they're both a half, and that one there's a third. Okay, so let's calculate the one on the top. The first and second are both gold. So how can I do that? I can go, and then I have the next part of the branch, don't I?
yeah.
So here, the next one has to be gold, if you took gold out here. Here, if you took silver out, the next one has to be silver. And in the last one, if you took gold out, then the next one has to be silver. And if you took silver out, the next one has to be gold. Right, so first and second are both gold. So how can I do that? That can be this part, or this.
No, it's the only one.
Oh, it's the only one. Yeah, it's the only one. Okay. So that's 1 over 3 times 1 times 1 over, and then the first is gold. So I can go this way or this way to get to gold first. So that is 1/3 times 1 plus 1/3 times a half. So on the top I have 1/3, and on the bottom I have 1/3 plus 1/6. So that's 2/6 plus 1. Is that a half? Which is 2/3. And this, I think this is the answer at the back, is it? Yeah. Now this result really surprises people. It really, really surprises people. Because if you just think about what's happening, you took out a gold coin. So which situation are you in? Which box must you have? You must either have the first or the third. If you have the first box, then what's your next coin going to be? Definitely. And if you have the last box, what's your next one going to be?
Silver.
Silver. And it seems like both of those boxes are equally likely, doesn't it? Like you could have gotten the first or the third one equally if you didn't get the second one. So it's very common for people to think as their answer should be a half. Because the logic people would think is, well, we either have the first box or we have the last box. And if we have the first box, we have gold. And if we have the last box, we don't. So it's 50-50. But it's not 50-50, it's 2 over 3. And this is a good, it's a famous example of how your instinct, your guess, is actually wrong here. It's not 1 over 2. The answer worked out to be 2 over 3. This example has a name. It's called Monty Hall. That's what it's called. This one here. Yeah. Okay. I think this is. I don't know if anybody would have gotten this, so I think it's one you probably should write down. What did you get, Mo? You got a half, yeah. By the logic I was saying. Yeah. This question was in, do you know that magazine, New Scientist?
Yeah.
So they had this as a problem in it. So they said, this question is the question that received the most letters of complaints ever from the public. Because people just couldn't accept that the answer was not 1/2. Just couldn't accept it. Because it really feels like it should be 1/2. Okay. Right, what's next now? Just so you know, there's one mistake on the answers for 97 and 99. So I'll just tell you so you can correct it. So if you look at page 99, answer 6. You see I have 0.57? That should have been typed as 0.857. And then if you look at 97, answer 9, it should be 15% and not 20%.
Those are 6 and 7.
They're swapped, yeah, we talked about that, yeah. And also on page 102, Mo, you said you noticed that a letter D is missing from the data in number 1. There's an extra D at the end there. Top of 102, in the data, there's a grey D missing at the end. Okay, what else do we need to see now? You have a question, Rob?
Yeah,
Which
I can't
one?
find it.
What was it about?
It's the addition rule, I think. I didn't highlight it, my mistake.
Do you remember what the topic was? I can.
Yeah, it's the addition rule.
Yeah, but what type of question?
I think it's number 8 or 7. I think it's 7.
You know, we said the answers for 6 and 7 are backwards at the back.
Yeah. Number 7.
Yeah, and okay, 7. The chemistry and physics, is it?
Yeah.
Yeah, okay, let's have a look at that. There are 20 students in a class, and they either study physics. You can either study physics, chemistry, or both. Physics, chemistry. Uh, 60 study physics, 70 study chemistry, and 7 students study both. So there's 7 students who study both. 60% study physics, and remember there's 20 students in the class, so 60% would be 12, wouldn't it? So if 12 study physics, then there must be 5 studying here physics and not chemistry. And then how many study chemistry? 70%, which is 14, isn't it? So this must be a 7 here to make 14. In total, what's that, 19? Isn't it? Is this 19?
Yeah.
So that means that's a 1 there. So my question is, what's the probability that you study physics and not chemistry? So that's physics and not chemistry. So physics and not chemistry is 5 over 20, isn't it? And the next one is chemistry and not physics. 7 over 20? And the last one is neither physics nor chemistry. Not physics and not chemistry. 1 over 20. So 25%, 35%, and 5%. Is that okay, Mo?
Yeah, I don't think this was the question.
Yeah, I don't think so either. Which one then?
I can't remember. This was a week ago.
Were you able to do question 4 and 5? Because these are the
Yeah.
questions in the medicine entry test. Check. Oh. We did one of them, didn't we? Yeah. Where is that question? All right. Well, if the probability is okay, then what about the frequency distribution?
That's easy.
It's just calculations, isn't it?
Just a table. You write numbers.
Yeah.
Nothing hard. And the averages is just, you know, you write the table and the ranges and then you get the average,
Yeah.
median, or which is even easier.
In your chemistry, what data did you collect? pH levels, wasn't it?
No, it was the volume of sodium hydroxide required to neutralize hydrochloric acid. It's a titration process, acid-based titration.
Oh, okay. So
you know the volume of HCl, and you.
so your data. Sorry, you're collecting data, and one of the data is volume,
Yeah.
and the other one is
pH
pH.
of the solution after it was mixed.
Yeah.
Because you used an indicator, like what you would know when it was neutralized. And
Good.
it was
Okay. So you're pouring something in
Yeah.
until it's neutralized.
Yeah.
And are you pouring it into the same thing or different things?
No, different thing.
The same thing.
No, different. It's a base over an acid.
So, like there's in the conical flask, there's a hydrochloric acid, and in
Yeah.
the burette above
Yeah.
it, there's sodium hydroxide.
Yeah.
So you put like 50 milliliters of sodium hydroxide in the burette and 25 milliliters of hydrochloric acid
Yeah.
in the conical flask, and you would turn on the tap and
Yeah.
just mix it slowly until
It's
turns
neutralized.
pink. Yeah, and
Yeah.
then you would note the volume that it took of sodium hydroxide. Then you can tell the concentration using the formula.
Oh, I see. And why do you repeat this? Do you repeat the same one many times?
Yeah, because you want to
So you had to take an average.
yeah.
Okay, good, good,
We had to do the error average as well.
good,
Yeah.
good. Okay. And have you all these calculations done? You don't need help with them?
Yeah.
Have these been submitted?
Yeah.
Okay, so that's taken care of then.
Yeah.
All right. And what about biology?
So biology said we don't need to do calculations. I don't know.
Just draw pictures, huh? Yeah. Okay. Right. Anything else then from the workbook? I can give you.
Can we do?
Yeah.
But I think it's long. 8
On what page?
frequency distribution.
What page is that?
102.
102.
Page. Oh, that's boring. I'm not doing that. That's boring.
Yeah.
That's so boring. You just have to put.
But I know why it shows 52.7.
No, Amjad, I must have said it 10 times yesterday. I said you don't have to put them in the table like this.
I don't. Okay.
I just did.
Okay.
There's like many ways to solve this.
Many, many ways.
Okay.
Many, many ways. I just picked something that I thought would be convenient. So if you look at the table I got, look at my boxes. I have like 1, 4, 7, 8, 5, 1.
Mm.
What did your one work out to be?
No, I didn't know from first that I should choose 52.7.
Yeah, but remember I said yesterday you don't have to.
Oh.
So like what was the smallest number in that?
I think 52.5.
52.5. No, it couldn't be 52.5.
It's
52 point what?
No, for me.
What is the smallest?
53,
53.1.
5,
53.1.
Yeah.
Okay, so I went 0.4 to the left,
Yeah.
and I must have
But I
gone.
went 52.3. Okay. 53.0.
You went 53.0? Good,
Because
good. It's fine. It's fine, yeah. Because your smallest number is still included in that.
yeah.
Yes, it's fine.
Is it always better to stick to whole numbers?
No.
Like, if it's possible to go like to the left by 2, for example, and it to be a whole number, should we always do that?
No. Not necessary. Because, like, okay, his first one's a whole number, but everything else is still a decimal.
Yeah.
So, no. No, Amjad, that process I showed you yesterday was just a guideline for making a table that's reasonably sized. But it's flexible. It's flexible.
So we don't need to do all of that.
No, but, I mean, how many boxes did you make in your table?
I think 5.
And why did you pick 5? Why didn't you pick 10? Or 2? Why did you pick 5?
What should I do?
Why did you make 5 boxes? Why not 6 boxes? Why not 4 boxes? Okay, that's fine. For me, I tried to pick the number of boxes that equals the square root of the size.
Which side? Okay, the side.
Okay, I'm stopping talking to you right now because it's not good for my health. Any other questions?
Sir, for number 10, I didn't attempt it yet, but what do they mean by class boundary?
That's the lower and the upper in
Min
each
and max, yeah.
minute, yeah. Within each box, each bin.
Yeah.
Okay. Say again? In which page? 96. Yeah, it's a small typo. Imagining people can only have brown or green eyes in that story, and the answer at the back is different. It should be 15%. Yeah. But it is a bit tricky, number 9. Were you able to do it? Okay, let's have a look at it. So, people either have brown eyes or green eyes, so not brown, and they're either male or they're not. And what do I tell you? Well, 70% brown eyes and 50% are male. So I'll call this X. So this here would be 0.7 minus X. And this one here, 0.5 minus X. And here we'll have to call it like Y. So I can say 0.7 minus X plus 0.5 minus X plus Y equals 1. Cancel, cancel. 1.2 minus X plus Y equals 1. Minus X plus Y equals minus 0.2. X minus Y equals 0.2. So minus there. But of course there's a problem. We only have one equation. We need to form a second equation. What can we say? This is the hard part. What is the second equation here? Because I didn't tell you anything else in the question. So you need to use a little bit of judgment here.
Can you use not, the not part?
Nah, I don't think that'll help us. There's another piece of information which I haven't given you, but I think it's reasonable that you assume it.
Not brown and male, right?
No? Have you done genetics in class? In biology?
Sort of, we touched on it.
Okay. I don't think your gender has any effect on your eye colour. They're independent.
Yeah.
You know, like if, whatever it is, you know, like if one parent is blue eyes and one parent is brown eyes, the distribution of the eye colours of the children, it's not affected by what gender the child is. It just depends on the parent. So I don't think gender and eye colour have any effect on each other. They're independent. You know, it's not like height. Okay, obviously your height is dependent on your parents' height, but it's also dependent on the gender that you're born. Eye colour, I don't think is like this. I'm pretty sure it's not. So we can say that they're independent events. Yeah.
Use the formula.
So we can use the formula that says, yeah. How do I get the first line? Oh, the total is 1. Yeah, yeah. Independent means brown eyes and male should equal, brown eyes times male. So that's x should equal 0.7 times 0.5, which is 0.35. And if you sub that back in there, you'll get y equals 0.15. So your Venn diagram now looks like this. Oh, that's a bit small now. What did I say the x was? 0.35, and this will be 0.35, and this is 0.15, and what's that? 0.15 here. And my question is, what is not brown and male? Not brown. That's this one here. 0.15 is the answer. 15%, which is what I said it was. Yeah.
This is why.
Yeah.
Because we took independent later on.
I know. So for this one, how you would have done it is you would have had to think very deeply about it. Well, I put it in towards the end to see if someone could figure it out. It was sneaky of me, that is true. Okay. What else do we need to see? Okay. Writing that down? I'll just get something here for you.
Sir, how did you get 15% then?
It's Y. I circled it in blue.
You said born male with green eyes.
Yeah, green means not brown. I'm imagining you can only have green or brown. I should have made that clearer in the question. Yeah.
Also, we can assume.
Well, no, you shouldn't really assume that. I should have really said that in the question. That was my intention, but then I realised, oh wait, no, there's more than 2 colours. Let's see if I can find a question here. What's it called?
So the probability is male, given that
For which
it's not
one?
brown, or is it
No, the question is just,
brown and not brown and male?
that's all, yeah, that's all. the medical example I remember seeing about before. Ah, it's okay. I'll give you another one.
Sir, there's people who missed
Oh, no, here it is.
the coursework stuff. Like,
What do you mean?
yeah, they didn't. Did they talk to you about it?
Oh, that's their problem. Yeah.
Really?
Well, I mean, it's not my job to chase up for people if they miss stuff in class, you know. Let's
So
see.
you better bet on Sunday night I'm going to be getting WhatsApp calls.
What's this coursework thing that's on Moodle?
Exactly.
Okay, let's see. I'll give you a medical example here.
We're handling the computer.
Submit Monday.
No, it's on Moodle. On Monday it's
Oh,
Moodle.
it's not a hard copy. Okay, cool.
No. So I'm not too worried about the number of pages then.
Okay.
So the question, yeah. This is a. It's a bit long. No, I won't do this one now.
Solve our confidence.
The question I wanted to do, I don't know, it's another famous medical example. I don't know how familiar people are with this. Do people know about things called cot deaths? Is this a term people have heard before?
No.
No?
What? That's
Cot deaths. It's just when newborn babies unexpectedly die in the cot. And it's not exactly clear how this happens if they...
Is it
if
lack
they
of oxygen?
possibly if maybe they turn and, you know, I don't know. It's just one of those things that seem to happen. I don't know if this gets much attention back in your home countries. Is this something people know about or have heard about?
I've
heard about it.
once in ever.
Yeah.
But it was related to oxygen
This really
stuff.
famous guy in UK where he was selling the cots that was not on babies.
That's possible too, but cot deaths is just something that's always seemed to have been around. It's quite rare though. The problem is, it's quite rare, but also, you know, the reason it happens, people don't know why it happens. So it's possible sometimes that the cause is actually parents, and it wasn't natural. But you can never tell. You can never tell. You know, you can't tell which one it is. So there was a case in 2002 of a parent who, unfortunately, their first child died of cot death and their second child. But
That makes it more likely that they messed up somewhere.
well, you see, this was the argument that the prosecution was making, but their calculations were not correct. So they made it seem like, the chances that it was innocent is like 1 in 73 million or something like this, whereas in reality it was 1 in 3. And the reason for this is because of the conditional probabilities. And I can give you a good example to help you understand this, okay? Imagine, you all know about the lottery. You know, you play once a week and you could win millions and millions of euros. So what do you think your chances are of winning?
It depends on how many people.
Yeah, so but like what type of number? Would it be 1%?
Less.
Much less. What would you think it would be? Probably like something like 1 in 10 million.
Yeah.
Yeah? Okay. So imagine the lottery's on tonight, and you know, they have the winner on TV, and then I go to the winner's house, and I say, you must have cheated. And they say, why must I have cheated? Well, the chances that you could win the lottery is 1 in 10 million, which is so impossible that you must have cheated. And like, there's something not quite right with that argument. What exactly is not quite right with it?
Because he was that one.
Yeah. And couldn't that be the same thing with the cot deaths? You know, and this is where it gets a little bit confusing. So what you need to be clear is that the probability that you win is quite small, right?
Yeah.
But the probability that you win is not equal to the probability that, you know, that you didn't cheat. So just because I say your chance of winning is 1 in 10 million, 1, 2, 3, 4, that doesn't mean there's 1 in 10 million chance that you're innocent.
Yeah.
As you said, that person just happened to be the 1 in 10 million.
Isn't it a half? Didn't cheat? The probability of not cheating is a half.
I'd say the probability of not cheating is quite high, because I can't really imagine how you could cheat.
Oh.
You know, that's the point. So,
Because you either cheat or not cheat.
yeah, but most people don't cheat, so. So anyways, the point being, I just don't want anybody to mix this up. Okay, and you can see this in medicine as well. So anyways, to summarize this up, the key rule here, and this kind of ties into your kind of what we were talking about yesterday about medical research. You can't use the data to form a hypothesis and a conclusion. Okay? Now what that means is you can't look at some data, you can't get an idea, and then at the same time get the conclusion. I'll give you an example. So, let's say Mo is the one who won the lotto. That's my data. I can't then also say, well, the chance of him winning is so small, he must have cheated. I can't use the same data to form a hypothesis and a conclusion. So, 2 babies dying of cot death is quite rare. So, if I saw that happen, I might have the hypothesis that the mother did something. Then I can't use the same data to form the conclusion.
Oh, okay.
You see, you have to use other data. So other data might be, does the mother have any evidence of child abuse in the past, for example? Or, you know, other things like this. From a history, yeah. That's the key message here. You can't use the same data to form a hypothesis and a conclusion. Because if you do that, the answer is always yes then. Yeah. Okay, see, I'm trying to make you good researchers in the future. Maybe, even if one of these little things stick, I think it's an achievement then.
What was the verdict of the case?
I think, let's see, I have it here. I believe her name is Sally Clark, the mother, and when this article was written, she was appealing the decision in prison. No, the chances that it was a murder was 2 over 3. I mean, that's not, you know. If I was on a bus and I said, the person beside you might be a murderer, but don't worry, it's not 100%, it's only 2 out of 3. I'm like, nah, I think I'll sit on another part of the bus, thanks. But still, if you were going to go to jail, you would like it to be a bit more certain than 2 out of 3.
Sir, the same concept can be said about lab reports and lab, right? Like, you would form a hypothesis, but you need extra evidence, which is...
No, well, really what's supposed to happen with lab reports is the hypothesis is formed before you collect the data. So, for example, the hypothesis could be, I don't know, whatever. You can cancel a base with an acid or something, whatever. And then you actually collect the data to check that hypothesis. But if you do a lab report, if you went to the lab and collect the data and then formed a hypothesis after you collect the data, then you can't use the same data again. You would have to do another experiment. Yeah. Let's see. Oh, it says here, I guess she was freed because it says now wrongly convicted. So they decided in the end that the evidence wasn't quite correct. And this case is famous because it was statistical evidence that made the difference.
Where was this? In what country?
It was the UK.
Okay. If it was the US, she might be still in prison.
If she was the US, she could have been executed by now. It's very hard to appeal a verdict of execution.
Yeah.
It's quite difficult.
Do you watch Forensic Files?
I don't. Is that like a CSI thing?
No, it's not. CSI is fiction. This is non-fiction.
forensic files.
Yeah. It's American, like, they also use
Cold cases, yeah?
statistics. No, it's usually cold, but they solve it.
Cold cases.
No, solved cold cases.
Yes, okay.
They,
Okay.
they also use statistics to say that genetics found on the victim's body is like what you said here.
That's another good example of how the statistics can be misleading. So they make it seem like a match is 99.999%, whereas if you actually calculate it properly,
There was this guy that was probably because of
the genetics. Yeah, no, these are all very good examples. I'll have to check that. What?
forensic facts. It's just on YouTube.
Oh, okay.
Yeah, there are full episodes on YouTube.
Nice. I'll have to check that sometime now. I could work some examples into the book then. Yeah.
Can I use the
Yeah, we'll finish there. So just to remind you, Monday is the submission on Moodle for the coursework. I'm happy to check or answer questions if you want to bring me anything. Okay? Yeah.
Can we email it to you just in case? Because last time I tried to upload something on Moodle, it went horribly wrong.
Upload it, and if there's an error, you can email it.
Okay.
But the time limit still applies. So it's
9 a.m.
9 a.m. and it's less 10% each day it's late. And late does mean 9:01. You can submit it early too, you know, you don't have to wait until 8:30 tomorrow. You don't want to work on the weekend too. Okay, fine. Right. Pretend it's worth 10%. No, you don't need to pretend. It is worth 10%. Okay. Yeah, good strategy. Okay. All right. I'll have you after lunch then, so we'll continue anyways with the simple, isn't it? I have you after lunch today, don't I?
Yeah.